Hi friends, today I will explain about micro-partitions and clustering in Snowflake. So how data is stored in micro-partitions, what is the metadata of micro-partitions, what are the benefits of micro-partitions, what is meant by clustering and what are the cluster keys, how to define cluster keys and how we can choose cluster keys so that it will improve the query performance. We'll explain all these things today. So what is meant by micro partitions? In general, whenever we load or insert some data into tables, database tables, it will be stored in multiple smaller blocks, storage blocks, right? So those are called partitions. Snowflake has implemented a powerful and unique form of partitioning, okay, that is called micro partitioning. So here in Snowflake we call that storage the data into partitioning concept as micro partitioning. Micro-partitioning is automatically performed on all Snowflake tables. So we don't need to do anything, admin kind of activities. Whenever we insert or load some data into Snowflake, it will be automatically micro-partitioned and stored in the storage layer. Okay. Tables are transparently partitions using the ordering of data as it is inserted or loaded. So whenever we load some data, that will be inserted into the micro partitions. Next time whenever we load again the data into those tables, it will be stored in the order we are inserting or loading the data into the tables. Okay. Snowflake is columnar based and horizontally partitioned. This is very important. Snowflake is a columnar database, you already know this. But here the data is horizontally partitioned. Suppose we have some 100 records, okay, and we have two partitions. So first 50 records will be stored in the first partition, and the next 50 records will be stored in the next partition, like that. So don't think like it can store only 50 or 100 records. Okay, I'm just explaining for example. Okay, and here if you see, Snowflake is a columnar based and horizontally partition, meaning a row of data is stored in the same micro partition. Suppose we have a complete record, right? That complete record will be stored in the single micro partition. It will not split into multiple micro partitions. Okay, all the columns of a single record will be stored in the same micro partition, not splitted into multiple partitions. This is very important, you have to understand. Snowflake is a columnar based, but the data is horizontally partitioned. Okay, that means a row of data is stored in the same micro partition. Okay, and what is the size of micro partitions in Snowflake? Micro partitions are as small as in size, and they are from 50, it can be vary from 50 MB to 500 MB. Okay, and even the data is compressed in the micro partitions. That means whenever we insert the data, after some time it will be compressed. Snowflake automatically determines the most efficient compression algorithm for the columns in each micro partition, so we don't need to bother about the compression here. Snowflake will decide which is the efficient compression algorithm, and it will apply on the micro partitions of Snowflake tables. Okay, so let's see diagrammatically how the partitioning works in Snowflake. Okay, so this is the logical structure. Whenever we do just select star from the table, this is how it appears. This is how the data appears in the SQL agents, right? So suppose if there are four fields in the table, it will show like this: type, name, country, date. Whenever we just run select star from the table, but in the background, in the storage layer, how this data will be stored in Snowflake. So here you can see in the right side. Okay, so you can see, suppose as we mentioned, Snowflake is a columnar database. The data will be stored in the columnar format. Suppose if you observe any row here, for example, just consider the second row 4C SP 11 2, type 4, name C, country SP, and date 11 2. So here we have highlighted this in the blue blocks, right? 4, type 4, name C, country SP, date 11 2. So this is stored in the columnar format, right? That's why Snowflake is a columnar database. But if you see, the entire record stored in the same micro partition. Suppose if you consider another row 2a uk 11 2a uk 11 so complete record is stored in the same micro partitions. So here you can see here there are four micro partitions: micro partition 1, micro partition 2, 3 and 4. And here we can see rows 1 to, so total here there are 24 records in this table. Okay, here you can see 24 records. So the first micro partition is storing 6 records, next one is 7 to 12, next one is 13 to 18, and the last one 19 to 24. But if you see, any record is stored in the single micro partition, right? Suppose if you see, we have highlighted another example 3xde and 11.5. So 3 here you can see that highlighted in the pink boxes, 3xde and 11.5. So this is how the data stored in the columnar format. I hope you are understanding. Okay, so even though Snowflake is a columnar database, but one entire record will be stored in the same micro partition. And this is how the data is divided into multiple micro partitions, smaller micro partitions in Snowflake. So this is very important. You have to understand what is the metadata of micro partitions. Okay, this will improve the performance of Snowflake queries a lot. Okay, so metadata is also maintained by Snowflake, which includes, so what are all the metadata maintained by the Snowflake? Metadata of micro partitions maintained by the Snowflake. Okay, number of distinct values for each field. Suppose if we have 10 fields, we have a table with the 10 fields. Okay, for each field it will store, what are the distinct values of each field. Suppose we have a table with the millions of records, and I have some 100 countries in that table, 100 distinct countries in the table. So those 100 distinct values will be stored as the metadata. Okay, so it is maintaining the distinct values of each and every field. Okay, and the range of values for each and every field. Okay, suppose if we have 10 fields in a table, for each field, so what is the range? 1 to 100 or a to z. So it can be something alphanumeric or alphabetical or numbers, but it will completely store the range of values for each and every field. Okay, and minimum and maximum value of each and every field. Okay, so if we have 10 fields again in the table, for each and every field, what is the minimum value it is holding and what is the maximum value it will be holding. So it will maintain that metadata and the other useful information to improve the performance. Okay, so these are the metadata information stored by the Snowflake. Okay, metadata of micro partitions. Okay, so metadata is a key part of Snowflake architecture, as it allows queries to determine whether or not the data inside a micro partition should be queried. This is very important. That's why the performance of Snowflake queries is very fast. Suppose we have a query where we are selecting the data of particular country. Suppose select star from the table where country equals to India. So what will happen? uh, Suppose there are the data is stored in 1000 micro partitions. Whenever we run query, so it has to go through all the 1000 micro partitions, right? but uh, but if we see here, it is storing Snowflake metadata is maintained by the metadata maintained by Snowflake gives the distinct values for each and every field. So for country, one of the distinct value is India, right? So this metadata is telling me like, so out of 1000 micro partitions, only 500 micro partitions are having the value country equals to India. So what will happen? So whenever we run some query, it will not scan all the 1000 micro partitions. It will scan only 500 micro partitions, because it is clearly saying only 5. This metadata is clearly saying that only 500 out of 1000 micro partitions having the country field country equals to India. So that is how it will improve the performance. The micro partitioning the metadata of this micro partitioning will improve the query performance a lot. This way, when a query is executed, it does not need to scan entire data set, but instead only queries the micro partitions that hold the relevant data, whatever now I explained with the example. Okay, so this process is known as query pruning, as the data is pruned before the query itself is executed. Okay, so we call this process as query pruning in Snowflake. That means uh, even though the data is stored in thousands of micro partitions, but metadata will tell us what are all the micro partitions to be scanned, how many micro partitions to be scanned. That we call as query pruning in Snowflake. Okay, so suppose let's see the same with example. Okay, so here this is the logical structure of my table. I have the same example where there are 24 records in this table, and I am running a query. Like the right side you can see the query, select type country from my table. Okay, where name equals to y. Okay, where name equals to y. If you see here, name field is there, right? Here name field is there, but if you see here, okay, where all we can see the name. Okay, only we don't have name y in micro partition 1, we don't have in micro partition 2, we have a record in the micro partition 3, and we have a record in micro partition 4. So what will happen here, instead of scanning all the 4 micropartition, because of the metadata maintained, and it stores the distinct values of each and every field, right? So for this micropartition, what are the distinct fields? A, B, X, Y, Z. Here B, C, X, Y, Z. So here A, B, C, X, Z. Here only A, B, C. So in these two micropartitions, we don't have the distinct value Y, but here we have. So the query will not scan all the micro partitions, it will scan only these two micro partitions. Okay, so why we have only two? That's why only the micro partitions that match this criteria are micro partitions 3 and 4. The query pruning has reduced our total data set to just two micro partitions. So the query pruning has reduced from 4 to 2 because of this micro partitioning, and because of this metadata of micro partitioning. That means which is holding the distinct values of each and every field of each and every field. Okay. Okay. Now, what are all the benefits of this micro partitioning? So now we know what is micro partitioning, how the data is stored in the micro partitioning, and even we have seen some of the advantages of micro partitioning. Now see clearly what are the benefits of micro partitioning. So in contrast to traditional static partitioning, which is available in the traditional databases, okay, Snowflake micro partitions are derived automatically. That means we don't need to specify any mechanisms. So whenever we insert or load some data into Snowflake, it will be automatically stored in the micro partitions. Okay, so they don't need to be explicitly defined upfront or maintained by users. Okay, even though it is uh, okay, so we don't need any maintenance activity for this. So by default, Snowflake will store the data in the micro partitions efficiently. Okay, so micro partitions are as smaller as size, as small as in size, that varies from 50 to 500 MB, so which enables extremely efficient DML and fine-grained pruning of faster queries. Okay, so if the micro partition size is very small, then we can apply DML commands like insert or delete or update very easily. So because the metadata is stored in the metadata is stored for each and every micro partition, right? Because of that, it will perform the DML operations only on the required micro partitions. It will not go through all the micro partitions, right? And the third one is columns are stored independently within micro partitions, often referred to as columnar storage. We have discussed this already. This enables efficient scanning of individual columns. Only the columns referenced by a query are scanned. Okay. So in our previous example, even I can explain this. So here, as the data is stored in the columns, okay, it doesn't even go through all the columns of the micro partitions. Okay, so here if we see the query select type comma country from the table, where name equals to y. Okay, so first it will decide only micro partition 3 and 4 are holding the value y in the name field, and it doesn't require to scan all the columns, right? It doesn't need to go through this date. Okay, so first of all, by the metadata it is deriving only 3 and 4 micro partitions check. And what are the columns? We need type and country. So out of this 4 columns, it will scan only these 2 columns. Okay, uh, type and country. It doesn't even scan all the micro partition, all the columns of micro partition. Okay, so as Snowflake is a columnar database, this is one of the advantage. Okay, and columns are compressed individually within micro partitions. This optimizes the storage cost, definitely, right? So whenever we store some data, after some time it will be compressed by the efficient algorithms that Snowflake has. Okay, so what is the advantage of this compression? Okay, definitely it will save the storage cost. Suppose if we have some 10 GB table, whenever we load the data, whenever we are storing 10 GB of data into the table, after compression it will be reduced to just for example it will be reduced to 5 to 6 GB or even 7 GB. Okay, so here we are storing 3 GB of space, right? So this compression is also one of the biggest advantage of micro partitions in Snowflake. Okay, so now let's see what is clustering. Okay, so what is clustering? So give me a minute. Okay, so whenever we apply clustering on some fields, what will happen? It will one micro partition or the based on the cluster keys, the micro partitions will store the relevant data. Okay, suppose in my previous example where I was saying where country equals to India, right? So whenever we apply cluster key on that um, country field, what will happen? All one country data will be stored in my one micro partition. Okay, and another country data will be stored in the another micro partition based on the micro partition size. Suppose a micro partition can hold two countries data. Okay, suppose India and Japan. Okay, so it will hold all the data. And if suppose if the micro partition is full while storing the Japan's data, it will split to next micro partition, but it will try to adjust as much as possible, like uh, it will try to hold based on the micro partition size. It will try to hold all the relevant data, all one country's data into one micro partition, next country's data into next micro partition, like that. So what is the advantage of that clustering? So as metadata maintained, right? Metadata of micro partitions maintained in Snowflake. Because of that, it will not scan the entire table. Now it has to go through only the micro partitions where it is holding the required data. So it will further the clustering will further reduce the number of micro partitions scanned in Snowflake, and also it will improve the performance a lot. Okay, I hope you are understanding. Whenever we apply clustering on particular keys, okay, it will try to hold all the relevant data of that keys into one micro partitions, like that. So we'll explain this while showing you the practicals. Okay, how the clustering will help in improving the performance, and how the data is stored in the micro partitions when we apply clustering. We'll see that in practicals. Just try to understand theoretically now. Okay, so whenever we apply clustering, all the relevant data of one field will be stored in the micro partitions. So based on the cluster keys we are applying. Okay, clustering is a key factor in query performance. It reduces the scanning of micro partitions, as I explained already. A clustering key is a subset of columns in a table that are explicitly designed to co-locate the data in the table in the micro partitions. Okay, this is important. So cluster key is not always a single key. So we can have more than one cluster key as well. That means we can apply clustering on two or three columns also. Okay, we'll see that in practical, or we'll explain that how we it will help. Okay, and also if you see the second line, that are explicitly designed to co-locate the data in the table in the micro partitions. Suppose whenever we are first time loading the data into a a table, okay, so it will not apply the clustering, so it will load the data in the order of we are inserting. But if the cluster keys are defined on the table, it will take some time to reorder the data based on the cluster keys we have applied. It will reorder the data and it will store in the micro partitions based on the cluster keys we have applied. So it will take some time. So if it is a smaller table, it may take seconds, and if it is a medium table, it can take some minutes. But if it is large table like hundreds of millions of data, then it may take up to 1 hour to reorder the data into the micro partitions. Okay, we'll see that as well in practical. So here you can see initially the data will be stored in the micro partitions in the order of inserting or loading records. Then it will be realigned based on the cluster keys we are applying. Okay, so we have to choose proper cluster keys. This is very important. So if you blindly apply cluster key on some column, it will not help. Okay, so we'll see how to choose proper cluster keys in the next slides. Okay, so we can define cluster keys on multiple columns as well. As I already explained, we can apply cluster keys on multiple columns. We can modify the cluster keys based on our requirements. This is called reclustering. Suppose while creating the table, we have applied a cluster key on one field. Okay, but later we realized that cluster key is not helping, and I want to apply the cluster key on another field. Okay, so we have alter statement where we can alter the cluster keys of the table. So that process we call as reclustering. Okay, so reclustering consumes credits. Number of credits consumed depends on the size of the table. Okay, so for reclustering, definitely it will take some time for reclustering, right? So it will consume some credits, and the number of credits, okay, this is a serverless task, we don't need to apply any warehouse for this. But it will apply Snowflake credits. Okay, and the number of credits consumed depends on the size of the table. It's a smaller table, like it is holding only lakhs of rows, it will take less credits. But if you are storing like millions or billions of data in the table, then definitely it will take large number of credits. Okay, okay, now see how the clustering will help in improving the query performance. Okay, we'll see our previous example itself, where I want to run the query. Select type comma name from the table, where um, name equals to y. Now whenever, suppose here I have applied cluster key on the name field. Okay, so in this example, this is our previous how the data was stored. So if we see here on micro partitions 3 and 4, the data was stored. But if we apply clustering on name field, okay, cluster by name, then what will happen? So all the similar names will be stored in the one micro partition. If you see this below part, if you see here, a micro partition can hold up to 6 records, and we have five uh, 5 records where name equals to a. That's why it is storing all 5 records in this one. And the next name is b, so we have still 1 record space here. That's why it is storing b here. And in the next micro partition, it is storing all b's and c's, and it can hold up to 6 records only, right? That's why first it has given preference to b's, then the next name is c. Like that, the relevant names are stored in the one micro partition, or the multiple micro partitions based on the size of the micro partition, right? So if we see here, all a's and b here, b's and c here, c and x here, and y and z here. So it is now whenever we run our query where name equals to y, so it has to scan only this micro partition, right? This micro partition 4 will be scanned because it is only holding the value name equals to y. So now in our earlier case, it was scanning 2 micro partitions. Okay, but here it has to scan only one micro partition. So definitely the performance will be very good, right? So that is the advantage of cluster keys. So if you see here in our previous example, it was scanning 2, here it is 1. But in real time, will be holding a table can contain millions of records or billions of records, right? Here we are storing only 24 records, but in real time we may deal with millions and billions of records. That time it will help. And micro partitions, it will be like hundreds and thousands of micro partitions will be there. So while fetching the data, this cluster micro partitioning and clustering will help a lot, okay, for improving the query performance. Okay, so whatever I explained in the previous slide itself, the data is now stored and ordered based on the value of name field. The micro partition 4 is now only micro partition that contains name values of y. When we execute our earlier query, now the query pruning will be re- reduce our target data down to just micro partition 4. So as I already explained, it has to scan only micro partition 4, which means our query has less data to interpret and thus will perform more efficiently. So whatever I explained in the previous slide. Okay, now how to recluster the data. Okay, suppose I want to apply micro. I want to apply clustering on two fields now. Okay. So earlier I applied only on name, but after some time I realized I want a micro. I want clustering on type and date. So how we can do that? Simply by using this alter command, alter table name, cluster by, and the fields. Okay, so I have a queries like this: select name comma country from a table where type equals to 2 and the date equals to 11 by 2. So I have to run so many queries like this. That means it has to fetch the data name and country where the type and the date equals to these values. That means I have to apply the cluster keys on type and date. That's why what I am doing. So we'll explain. So how to choose a cluster key, we'll explain in the next slide. But just understand how we can alter the data and how we can recluster the data. So whenever we alter table like this, again the data inside the micro partitions will be reclustered. Earlier it was clustered by names. Now we can see it is clustered by type and date. Okay, so it will apply like this. Earlier the data was like this, and the data after reclustering the data will become like this. Okay, so you can see all two 11 by 2 are stored in this micro partition. All 3 11 2 or 4 11 2 are stored in this micro partition. All 5 and 1 come here. Like this, the data will be stored in the micro partitions whenever we apply clustering on multiple fields. Okay, so now how to define cluster keys. Okay, there are two ways. The first one is we can apply the cluster keys at the time of creating table itself. Okay, so this is the syntax. So we can put this cluster by inside or outside. Okay, so here after the column names we can put cluster by of this, or at the end also after create ddl we can mention cluster by like this. So while creating the table itself we can define cluster keys. The next way is modifying the cluster keys on existing table. Suppose initially we felt like the clustering is not required. That's why we created a table with no cluster keys. Later I have realized, okay, I need because my data size is growing and my query performance is not good. Now I want to define cluster keys on the existing table. Okay, so this is how we can define the cluster keys. Alter table name, cluster by, and the fields I want to apply the cluster keys. Okay, so both ways will work. We can apply cluster keys at the time of creation of table, or we can alter the table later to apply the cluster keys. Okay, so now choosing the cluster keys, which is very important. So how can I choose my cluster keys so that it will improve the query performance? Okay, so Snowflake recommends defining cluster keys on columns frequently used in the filter conditions. Suppose in our previous example we have seen where name equals to y. So if users are running that query a lot where name equals to, or where country equals to, or where order date equals to, then we have to apply cluster key on that field. So what are all the fields we are frequently using in the filter conditions, that means in the where class, apply cluster keys on those fields so that the query performance will be improved a lot. And the second one is columns using as join keys. So if we have big queries where we are joining multiple tables by using join columns, right? So join columns are very important to join two or more tables. So Snowflake recommends use cluster keys on those join columns so that the query performance will be improved a lot. Okay. And suppose if we are using any functions or expressions frequently, suppose if I want to calculate year of some date or some substring of some medical code. Okay, so Snowflake recommends define cluster keys on those functions itself. Suppose I have a year of date, right? Apply cluster key on year of date. We'll see a example like this today. Okay, and if I'm using this substring of medical code 1 comma 6 multiple times, the users are running this query with this substring, then directly apply cluster key on this substring. Okay, so it will also improve the query performance a lot. So whenever if our table size is very large and if I want to uh, cluster my table, so these are the three things I have to check before clustering. So I can cluster by my table and the columns frequently used in the where class are the filter conditions, and the columns used in the join keys, columns used are the join keys, and the frequently used functions are expressions like this. Also, Snowflake recommends define cluster keys on large tables and do not on small tables. So because anyway if the table is smaller and whenever we run our query, the data will be retrieved in milliseconds or microseconds. So why you need to apply clustering? Okay, unnecessarily clustering will consume some credits, right? So don't define cluster keys on the small tables. If the table is very large, it is having millions and billions of records, then only define cluster keys on those tables. And second one is don't define cluster keys on more than 4 columns. Okay, so Snowflake is recommending, so you can apply clustering on maximum of 4 fields, don't apply beyond that. So it will take a lot of time to recluster the data, or it will take a lot of credits. Okay, um, unnecessarily lot of credits will be consumed. Okay, and even it will not help if you apply cluster on more columns, it may not improve the query performance. Okay, so these are the two recommendations from Snowflake while choosing the cluster keys. Okay, so if you want to know more about the micro partitions and clustering, you can go through these links. Okay, this will give more details. What are the micro partitions and what is meant by clustering? How clustering will help in query performance? Okay, everything you can find out here. Okay, okay. Now let's see the practicals. Okay, so how the data will be stored in micro partitions and how we can cluster the data by using cluster keys and what is the advantage of clustering, we'll see now practically. Now let's see the practical implementation of clustering, how it works. Okay, so let's go to Snowflake account. Okay, so open a worksheet. Okay, so I have prepared all the queries already. Okay, just I'm copying all those queries as it is here. And so before practicing, okay, we need some practice data, we need some sample data, right? So it's may not be possible to load hundreds and thousands of million records for our practice from AWS or Azure now. So we can use the sample data provided by Snowflake. Okay, Snowflake is sharing so much data, right, for our practice. So let's use that data. How to use that? Okay, so first of all, go to data tab. Okay, so here you can see private sharing option. Okay, so here you can see the databases Snowflake is sharing with us. One among that is sample data. So how we can get this data into our databases? Okay, so here there is a option to get the data. Click on that get shared data and give a name to that database. I already explained this in my previous videos, but explaining again now. Okay, so I am giving the name sample data and let's click on get data. Now you can just click on view database. Okay, so here it is showing showing us sample data database has been created, and there are a lot of schemas and lot of tables under every schema for our practice. So now we can use this data for our clustering practice. Okay, so let's go to worksheets again. Okay, so first of all, now I want to create a database. If already the database is not exist, we can create a database for our all practice work. Okay, so the command is create database if not exist MyDB. That means if the database MyDB doesn't exist already, it will create, otherwise it will ignore. So in our case it's already available. Okay, so just run this command, nothing will happen. It will simply say the database already exists and the statement successfully completed. Okay, so the database is there, now we can see. Okay, now create a table. Okay, so I'm creating a table with no cluster keys first of all. So create a table with no cluster keys. You can see here I'm not defining any cluster key in the table ddl. Okay, so let's create a table. And before that, if you are in other schemas, okay, set your context first where you want to do all this work. So I want to do all this work in the MyDB public schema. Okay, so I have selected that. I am just creating this table, create or replace table, public dot customer non cluster. So I am not applying any cluster keys, right? So table has been created. Okay, now I want some data for the practice. So I'm getting the data, I'm loading the data from the sample data we just got from Snowflake, right? So the command is insert into this customer non-cluster table, the table we have created just now in the above step, and select star from sample data tpch sf1000 schema and the customer table I'm taking for our practice. Okay, so run this command. So as there are almost 150 million records in this table, it will take some time, some minutes to load all these records into this non-cluster table. Okay, so meanwhile you can check here in the database pan. So we have created the tables, right? Created a table, customer non-cluster table, and the data is being loaded into this table. So in next step, what we will do, so we will create a table with a cluster key. Okay, so if you see the table here, so create or replace table public dot customer underscore cluster. In the above example, we have created a non-cluster table. Here I am saying, just for our reference, for our easy understanding, I am naming the table as a cluster or non-cluster. It's not mandatory to mention like this. Okay, so and if you see the table definition, it's same column I am taking here also, but I am adding in one extra class, cluster by c nation key. So here we have so many columns, and among them I want to apply my cluster key on this nation key. So here nation key is one of the field in this table. I want to apply nation cluster key on this nation key. Okay, so this is nothing but nation means countries. So some numbers given for the countries, right? So I am applying the cluster on this one. Okay, so if you see, our previous query was completed and 150 million records loaded into this non-cluster table. Now let's do the same. Okay, so I'm creating a cluster table with cluster by on this nation key. Right. Okay, so I think we have to define this here only. Yeah, sorry for that. Okay, so let's create the table with a cluster key and nation by. So now the customer cluster table has been created with the cluster key c underscore nation. Now we have to load the data, right? We have to load the data into this table as well. So I am taking the same statement, insert into table customer cluster, and select star from the same data. I'm taking the sample data we just extracted from the shared database, right? So I'm using the same table, sample data tpch sf1000 dot customer, and I'm loading the entire data into this customer cluster table just now we have created here. Okay, so let's run this. Again, this may take almost 2 minutes to execute. Okay, that's fine. So what after? loading the data into the table. Okay, now we have to execute our queries. Okay, so after loading the data into this table, again it will take some time for the clustering. Okay, if it is a smaller table, it will happen within seconds. If it is a medium table, it will happen within minutes. But now it may take some 30 minutes like that, because we are loading 150 million records of data right into this. That's why it may take some time to reorder the data based on the cluster key we have applied. So now what we can do, we can wait some time, and later we can execute these queries. Okay, because when after inserting the data into this customer cluster table, it will take some time to reorder the data based on the cluster key we are applying. So we can execute the select queries and observe the difference between non-cluster table and cluster table after 30 minutes. If you run immediately, both will take same time, because the data inserted in the same order in the both tables. But for clustering, for the clustering to get effective, it will take some time, so we can execute these commands after some time. Okay, otherwise I have same set of data loaded into the tables in another Snowflake account. I will show you these queries now. But for in your case, after loading the data, wait for 30-40 minutes, then execute these queries. You will get the difference. Okay, so data has been loaded into this table. Okay, I have same data available already in another Snowflake account. Okay, so I have copied the same here. That's why last time whenever I executed the queries, I got these results. I have noted down the time taken and number of partitions scanned. Now let's see the same. So before doing that, I want to do two things. First of all, let's see my warehouse is active or not. If it is active, I have to suspend it, because if we don't suspend the warehouse, then local disk cache may be effective, because I ran the queries already, right? So just to ignore that, I want to, okay, it's already in suspended state. As well as I want to turn off the results cache. So if you are confusing with the results cache and local disk cache, you can watch my previous video on cache in Snowflake. Okay, it will clear all your doubts on caching in Snowflake. Okay, now as the data is already available here, let's run these queries. Okay, so we have loaded the data in both uh, customer cluster table and customer non-cluster table. There are 150 million records are available. If you want to check, you can see here. Okay, tables, so customer cluster, so it is saying 150 million rows are there. Okay, customer non-cluster table also, there are 150 million records are there. Okay, so now let's run the select queries. So what I am selecting here, if you see here, select star from public customer underscore non-cluster table, where C nation key equals to 2. I am running this query because we have applied the cluster key on this nation key only, right? So just to see the difference, I am running a filter on this table, on a filter on this column, nation key equals to 2. Okay, so let's run this query and observe the query profile. So it took 15 seconds to run. Okay, same as the last time. And let's see the query profile. So query profile give us the details of micro partitions. Okay, so if you see here, these are the total micro partitions. That means 150 million data, customer data stored in total 420 micro partitions. Means this table occupied total 420 micro partitions, and it has scanned all 420 micro partitions to fetch our data. So if you see here in the flow, it applied the table scan on this table, and then it applied the filter where nation key equals to 2, and it is showing us the results in some 15 seconds. Okay, so you can see that, right? So it is scanning entire 420 partitions. because we haven't applied any cluster key. Okay, so that's what I have noted here. Okay, it took 15 seconds and all the 420 out of 420 micro partitions scanned. Okay, now I want to run the same query on the clustered table. So this is the clustered table, right? Select star from cluster table where nation key equals to 2, and let's see the difference. So it took just 7.3 seconds. Okay, 7.3 seconds it took. And let's see the micro partition scanned in this case. If you see here, out of 482 micro partitions, it is scanning only 22 micro partitions. That means nation key equals to 2. That data is stored only in the 22 micro partitions. Okay, because we have applied the cluster key right on the table, on that field nation key. That's why all related nation keys are stored in one micro partitions. Like that, nation key equals to 2, this data is stored in only 22 micro partitions, and the metadata maintained by Snowflake tells us this nation key 2 is available only in 22 micro partitions and scan only those. That's why it is scanning only 22 micro partitions. Okay, and it ran in just 7.3 seconds. That means it took only half of the time because of clustering, right? And it is scanning only 22 micro partitions. Because of this less number of partitions scan, it is taking less number of seconds to fetch the results. Okay, you can see the difference right here. Okay, now let's go to another example. Okay, another data set where we can apply cluster keys on functions. Okay, and we can apply cluster keys on multiple columns of a table. Okay, so here we can create table like this. So here instead of creating the tables and load the data, I'm directly creating the tables in this step. Create or replace table. Okay, as select or select star from this sample data. Now I'm taking orders table as example, and I'm creating a table orders underscore non-cluster as a select star from the sample data dot tpch 100 and orders. Even there are 150 million records in this orders table. Okay, so whenever I have already loaded this data, that's why I'm not running now. But whenever you run this command, some 150 million records, a table will be created with the name orders underscore non-cluster. And whenever you run the next query, okay, so this is the query, create or replace table. Okay, public dot orders underscore cluster. Okay, so here I am creating a non-cluster table, then I will apply by using alter command. So in the first case I have just created a non-cluster table. In this case I am creating a table, cluster table. Okay, just I am just naming, instead of non-cluster I am naming cluster, and then I will apply the cluster key by using the alter command. I want to show you the two ways. One is at the time of creating a table. Okay, one is at the time of loading the data. If the table is already exist, how to add the cluster key for that table by using this alter command. Okay, so I have already executed these two commands, and tables you can see in the left pane. Okay, orders clusters and orders non-cluster. Okay, in your case you run these two commands, the data will be loaded wh- when you are practicing. Okay, and it will take some time for clustering again. So if you want to apply the cluster key on this order date, what you have to do? Okay, you have to run this command alter table year of order date. Okay, so let's run this otherwise here. Okay, it may take a lot of time, but let's run. In the other account where I haven't loaded the data, or where I haven't created the tables, right? In another Snowflake account, I'm running here. Okay, it may take some time, and meanwhile we can see the other queries. Okay, so what after applying the cluster key on this table. So whenever I try to fetch this data, so here if you see the difference is here I am applying the cluster key on a function. Okay, so order date is a date field, but I don't want the date. I want only the year of orders. That means here the data is available from 1995 to 1999 like that. Okay, so I want to apply the cluster key on the year. I in my filter conditions I never apply complete order date. I apply only year of that order date. So this is a function to get the year from a date field. If I want to extract only year from the date field, this is the function we use, year of order date. So I want to apply so I want to apply cluster key on this function. Okay, so one table got loaded. Let's run this. Okay, so let's load the data into this cluster table as well. Okay, so if you see here I have applied cluster key on the function of order date field. Now what I will do, I will try to execute these queries. Okay, select star from this non-cluster table where year of order date equals to 1995. So we have applied cluster key on the year of this one, right? So whenever I execute this query, okay, it will take around it took some 17 seconds, and it was scanning 87 partitions out of 229 micro partitions. So here the data was stored in 229 micro partitions, and this 1995 data is available in the 87 micro partitions. When I did not apply clustering, okay, so this data was available in 87 micro partitions. But when I applied cluster key on this table, in the cluster table, when I run the same query, here it is fetching the data only from 36 micro partitions. That means after clustering the data, this 1995 year data has been adjusted in only 36 micro partitions, because whenever you apply cluster key, what will happen, all the related data will go to same micro partitions, right? That's why it took only 36 micro partitions. When you don't apply cluster key, it may take us it took 87 micro partitions. Okay, you can see that, right? So now the data has been loaded into both the tables. Now let's run this. Okay, so the table we have applied cluster key on this table. Okay, now it will take some time actually. Okay, but let's ignore that. We'll run the queries at the end. Let me explain the next part as well. Okay, it will take some time to cluster the data based on this order date, right? So meanwhile we'll go to the next discussion. So here, after examining this, okay, now in future my requirement is changed. Okay, I want to fetch only high priority orders. Okay, of some particular year. Okay, suppose in the year 1996 I want to fetch only the order details of urgent order details. So there are orders like 1 urgent, 2 high, 3 medium, 4 low priority. Like there are some priority orders. Okay, now I need to fetch only the high priority orders. That means urgent orders for the year this. That's why there are so many users who are running this queries. Okay, that's why I am applying my cluster key on year of order date as well as the order priority. Okay, so whenever we apply this like this, it will recluster the data, because in our earlier example we have clustered it only by using year of order date. And whenever my requirement is changed and users are running the queries applying filter on this order priority as well, okay, my requirement is changed, and I am applying the cluster key on both of these fields, order date and order priority. So whenever you run this command next time, it will recluster the data. For reclustering again it will take some credits and it will take some time for reclustering of data. Okay, so we have to wait for that. Okay, then I will execute the same queries. Select star from this non-cluster table where year of order date equals to 1996, and order priority equals to urgent. So when I ran this previous time, last time when I executed this query, it took some 5.5 seconds, and it scanned almost 87 micro partitions out of 229. Okay, but after reclustering, okay, so I ran the same query on the orders cluster table. Okay, where order date equals to year of order date equals to 1996 and order priority equals to 1 urgent. So next time it took 4.9 seconds. You ignore the time difference, it's very less in both cases. Okay, and it scanned only 10 micro partitions out of 234. In our previous example, when we applied the cluster key on this order date, it took 36. Now we have one more filter, right? That's why it is not even scanning 36 micro partitions. Out of this 36, urgent priority data is stored only in the 10 micro partitions. Okay, so now if you see, this 1995 data is stored in the 36 micro partitions. Out of this 36, again there are some 5 types of priorities. Now the one, this urgent priority data is stored in only in 10 out of these 36 micro partitions. I hope you are understanding. It may be little confusing, but try to understand. Okay, so so suppose one urgent priority uh, orders are taking 10 micro partitions, and some next priority high priority orders are taking some 10 more uh, partitions, and low priority orders may take some 6 or 7 partitions, it may, right? So out of the 36, okay, now whenever we applied cluster key on this order priority, they are taking only 10 micro partitions. Okay, so whenever you run these queries in the sequential order, you will get to know every time what you have to do. Run the query and observe the query profile for the same. Okay, so it's a little while, right? Now let me try to execute this table. Okay, so we have applied cluster key on this order date, right? It's been a while. Let me try to execute these queries. Okay, so I am running this select star from non-cluster where order date equals to 1995. In the other account, what I did, I have applied already the cluster key on both the fields. That's why I'm not showing here. I will show the next example in this other account. Okay, so it took 18 seconds. 18 seconds. Okay, and let's see the query profile. Okay, it is scanning 86 micro partitions out of 226. Okay, 86 out of 226. Okay, now let's try to run this query. I hope it's clustering is completed. If not, we have to wait more time. In general, it will take up to 30 minutes for 150 million records. Okay, it took 19 seconds. That means it hasn't applied the cluster yet. You can see that here actually. Okay, it has applied already the cluster. You can see, even though this time difference we cannot get because 18 and 19 similar. Last time when I executed the same, it took only 11 seconds. Okay, this is ignorable difference in seconds, but you can see the difference here. So out of 228 micro partitions, it is scanning only 35 micro partitions. That means this order date 1995 data is stored in only in the 35 micro partitions. Okay, so that's why it is going through only less number of partitions. It is not going to all 86 micro partitions. Okay, I hope you can see the difference. For now, just ignore the this seconds difference. It will vary. Next time when you run the same queries, after turning off the results cache, it may take less, 1 or 2 seconds less or like that. Okay, ignore this, but just you can observe this difference in the number of partitions scanned. Okay, so now let's apply the cluster key on both the fields. So this is how we can apply cluster key on the multiple fields of a table. Okay, so this has been executed. Okay, now let's run these queries in the other Snowflake account, because again it will take some time, right? So what we can do, so I have already reclustered the data by using these two. Okay, if you want to see this information, cluster information, so we have a command called select system clustering information. Okay, system clustering information, and the table name we have to provide. Suppose I want to see the cluster information of this one, right? So where I am saying I have applied cluster on two keys. Okay, so let's see that. Okay, so this is the result, and it is saying cluster by keys. Okay, linear, that means it's a function based column. Year of order date and order priority. I have applied clustering on these two fields, year of order date and order priority. Now let's run the queries. Okay, so if anyone is asking you how to see the cluster information of a table, so you can see that information in the table DDL. Okay, and you can see here in this table system cluster information, and you have to provide the table name here. Okay, so now let me run these queries. So my query is select a star from this non-cluster table where order date equals to 1996 and order priority equals to 1 urgent. Okay, so let me run this. So it took some 5.6 seconds, and let's observe the query profile for the same. Okay, so it is scanning some 73 partitions out of 229. Okay, so 73 out of 229 it is scanning. Okay, earlier I executed for 1995, that's why it gave me 87. Now it's 1996 I am executing, that's why it's giving me 73 micro partitions. Now let's run the query, same query on the cluster table, where we have clustered the data by using two fields, order date and order priority. Okay, so I'm running the same query on different table, cluster table. Okay, it took around 4.8 seconds, which is less than the previous one. Okay, and let's see the micro partition scanned. So here you can see only it is scanning 10 out of 234 micro partitions. You can see the difference, right? What will happen if we apply proper cluster keys? Okay, so that's the difference. I hope you are understanding this. Okay, so 10 out of 234 micro partitions it is scanning. Okay, so this is how we can apply cluster keys, okay, on function based columns, and this is how we can apply cluster keys on multiple columns. And Snowflake recommends only apply cluster keys up to maximum of 4 columns, don't go beyond that. Okay, and we have seen how to recluster the how the data will be reclustered after applying the cluster keys on multiple columns. Okay, so we have seen everything. Okay, I hope this will help you, and if you have any doubts on this clustering or micro partitions, you can reach me on my email. Okay, and don't forget, please subscribe to my channel. Thank you. Thanks for watching this video. Please subscribe to my channel, and if you have any doubts, you can reach me on this email ID. Thank you.